Hello everyone. Today is the 22nd day of Leetcode 75 challenge. Let's begin with the 22nd question. Question 1657. Determine if two strings are close. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. We are given two strings, word 1 and word 2, fine. And you need to check whether these two strings can be made the same but using only two types of operations. Fine. And what are those operations? That operation one is you can swap any two characters in the strings. This means you can rearrange the letters however you want. Fine. Basically, if you have A, B, C, so you can swap A with C, so it will become C, B, A. This is the first operations. And second operation is you can change all occurrences of one character to another and do the opposite at the same time. This means two letters can switch places throughout the strings. Basically, if you had A, B in one string, and let it be D, not D actually, let it be B, and A. So you can just replace this A with B here, which becomes this, and this B can be replaced with this A. So we can see that these strings get converted to the same, which is word 1, or this is word 2, right? So word 2 basically gets converted to word 1, right? This is what the second operation says, that if you have uh, you know uh, n number of A's here, for example, and you have n number of same letter here also, you can just completely have to change. You cannot do like if you have three times A here and you have two times B here, or three times or four times, whatever it is. But you're seeing that if you take two A's from here and just replace two B's, that is not possible. Either you have to take the complete all number of A's and replace all number of B's, or you don't, right? Please keep that in mind. This is what the second operation says. Now, after that, you can use these operations any number of times on both the strings. There is no foundation on using these operations, fine. And your task is to find out if it is possible to make two strings equal by using these operations. Whether we can make both the strings equal or not after performing these two operations unlimited number of times. Okay. If it is possible, we return true. If it is not, return false. That's all. That is the question. Nothing else. Basically, word 1, we have to make word 1 equals to word 2 or word 2 equals to word 1, any way possible, fine. We can replace the characters from this can come to this part and this can come to this part, or you can change the occurrences, or the second operation of the one character to another. If these three characters are A and here we have three times C, you can completely change this to this, fine. So these are the two things you can do. I hope you understood the problem explanation. Let's look at the constraints. So word 1 length and word 2 length would be from 1 to 10 to the power 5, and word 1 and word 2 contain only lowercase English letters. Fine. I hope you understood the explanation. Now let's move to the next slide. Let's understand the input output of the problem. So word 1 is given here as A, B, C, and word 2 is given as B, C, A. Now we know that operation 1 says that we can replace the characters or letters. Fine. So if you can see here, if B is here and it is here, right? So what if in word 1, if we replace this B and C, let's see what happens. It becomes A, C, B. Okay. And what if we replace A comma B, A and B from here? What we get? We get B, C, A. So after two operations and only using the operation 1, we could get VCA. Right? We didn't do the operation 2 here. So that's all right. In example 2, word 1 is given as A and word 2 is given as double A. Now you can see here it gives false because A cannot be converted to 2 times A, right? Basically, you cannot increase the characters, right? You have to use what you have. So, or you cannot delete it also, right? So this is not possible in either of the way because swapping the positions or changing the frequencies of the characters cannot work here because the length of both the words are not same. So this returns false. Fine. I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. So let's build up an intuition by taking a practical example. Like now let's imagine you are in charge of two letter tiles of boxes. Basically, you have two boxes which contains tiles which have characters imprinted on them, right? Like tile, this is one tile, character imprinted is A, and so on, right? So what you can do is that you can you can mix the tiles in the boxes. Mixing the tiles basically means swapping the tiles, fine. Or you can just check if this is the thing. You can if swap all tiles of one letter with another existing letter. Basically, if you have three A tiles here and three D tiles here, so you can just swap these three tiles with three D tiles, fine. But keep in mind, you can do that, fine. That is nothing. It has to be equal numbers, fine. Okay. But you cannot introduce any letters or throw away any. Basically, you cannot increment any letters or decrement any letters. Now your job is to check if you can make one word exactly like the other using only the two allowed moves. Okay. I hope you understood the practical example of the intuition. Now, how are we going to solve it? Imagine this is a tile of box, making it a bit long here. You have A tile three times, then you have B tiles, then you have C tiles, and here you have B tiles three times, and then A tiles, then C tiles. Okay. So you see here, if we want to convert, if you want to make whether the words are equal or not, first and foremost thing, which is the most common and the first thing you should come into your mind is that whether the length of the length of the boxes or the number of tiles in both of the boxes are equal or not. Because if I have five tiles in one box and four tiles in another box, you cannot make them equal because the length is itself not equal, right? So first we need to check if both words are exactly of the same letters or not, or you could say equal of length or not. Fine. If it is done, if the length is equal, now you can proceed to think of other things. Also, you have to keep in mind, okay, we had the understanding that lengths are equal, so there could be a chance that we can do the swapping. Now, if in this case you can see that if you replace this triple A's with this triple B's and then this double B with this double A, you will get the same word. Fine. But if you have B here, fine, and you don't have B here, but you have say what not B, let it be E. You have two E's here. Now it is not possible. Let me tell you why. Question specifically says that first thing you can swap, fine. Second thing, when you replace this character, like the three A's are there, right? So you could only replace these three A's if there are a number letters of three, three letters exactly of that length. Basically, three B's are there. You could replace this. Now also bring a thought in your mind. First, we checked that length of word one should be equal to length of word two, which is a very most important thing to proceed with. Second, you have to check if the word has to be equal. You cannot add any extra letter or remove any extra letter from it. As it is written here, you cannot introduce new letters or throw away any new letters. Also, as we saw in our example explanation, in this A was there and double A was there. Since you cannot introduce new A or you cannot remove one A, you have to deal with what is given to you, right? A, and these are not equal. From here, we can find that it has D, two D's and two E's. And when you check the uniqueness, you see that you have A, B, C, and D in first part and B, A, C, E. So even if the length is equal, total number of the character type is not equal. Basically, you have A, B, C here also and here also, but you don't have D here. Instead, you have E. So this has to also be equal. So from there, we can also say that if length is not equal, we can return false. And if the length is equal but the characters are not same, we will return false. And even if the characters are same, then we can think of doing the other two operations. Fine. We took out the two. We were able to figure out these two things from our intuition. Okay. It's nothing much complex about this problem. The problem seems to be a medium one, but it's not actually. It's very easy. Just put your basic understanding here. So what have I written here? Do both words have the same letters? As I said, we need to check if both words use exactly the same letters. Like it's ABC here, so ABC is there and ABC is there, right? But if you have XYZ, the length is equal, right? You can see this length is equal in both double X, double Y, double Z, and double C, double B, double A, right? But the characters are not equal. So you cannot, it's impossible to convert XYZ to ABC, right? Because you cannot add or remove characters from it. So if one word has A and other doesn't, they cannot be transformed, period. Which means it's not able, we will return just false. So from our intuition, we were able to figure out two things. Okay, let me write it here. First thing, length has to be equal. Second thing, I'm writing here as characters, right? Character should be equals to character of 1 should be equals to character of 2. Okay. Now, after this, we can perform the operations. Now, if you just uh, keep one thing in mind, we don't have to actually do the operations. Why? Because the question asks us to return true and false. Fine. They are not asking us to return, the number of operations or the resulted string, whatever it is, right? They're just asking us whether it is possible or not. So we don't have to do any kind of operations. Fine. Okay. So that is clear. We don't have to do any kind of operations. So how we will figure out whether the strings can be converted to the same thing or not? Fine. So if you can think that, let's take this example. A, B, B, and C, C. Fine. I have to convert it to supposedly, let's take another example. Mm, let's take ABC and BCA. Fine. Oh no, no, this is only fine. Let's take then this is A, right? We will convert it to BB and let it be CC, let it be AA. That's all. Okay. Now we since there was a constraint that if you want to transform this complete A, you know, to this B, you can do that. For that, we need to know what? We need to know the count of A and the count of B's in both the words, right? And also that is the fun thing. So what we can do for that? We can just store the count of 1, which is 2 here, B, which is 2 here, C, which is 2 here for word 1. And for word 2 also we have 2, 2 and A also 2. Okay. From here we can figure out that we have known the count. Now there could be one issue also. Since now we know the count that, okay, this is the count of A and B, we can just iterate the count array, or we could use dictionary to store the count here. If we just do that, we will check, okay, A has two counts. So does any other character has two counts in it or not? Fine. We can do that. We can just swap the values. That could be much easier task to do. Fine. But what if you had 3 times A, fine, 2 times B and 1 times C, and here you had 2 times A, 2 times B, and 2 times C. Now you say that in word 1 we have 3A, 2B, and 1C, fine. And in the second we have everything 2, 2, 2. Now length, is that equal? Yes, length is equal. Fine. Does they have, yeah, characters are also equal because first string also just has A, B, C, and second also has A, B, C. So these two conditions gets fulfilled. Now, if you want to swap, So what was the condition? If you try, no, if you try to convert this A to supposedly B, just take an example. The B has to also have the count same as A first of all, and you just cannot take partial count from it. You have to take complete count of B, which is 3, and replace it with A, which is 3. Fine. But here, if you see, A is 3, and here A is 2. So if you even if you think that okay, what if I use this A or if I use this B to convert something? You cannot, because we already have matching B's here. We just left with C, right? But we have three A's. So it becomes a kind of impossible task to convert or to swap the values. If you can understand, but you cannot do anything of these three A's, right? You cannot just swap, or you cannot just swap in place or swap it with the other word. So this becomes false. Now, how to know whether this variable could be whether the two words, even if they have the equal length and equal number of characters, how do we come to know that whether we can swap it or not? What if we store their count somewhere and sort it? Fine. If we sort it in increasing to from increasing order, you will get 1, 2, and 3 for this, and for this you will get 2 comma 2 comma 2. Now if you see, okay, 1 and 2 are not equal, we return false, because even if there would have been a case, let me take another example to make it more clear to you. I hope you are getting the intuition what we are trying to do here. Okay, let me take another example so it makes more clear. Supposedly you had A one times B, sorry for the comma, I have to remove the comma. Hmm. And then you had, C two times B. Suppose take it two times B and three times A. So you know that AB's first length is equal, second characters are also equal. Two checks are done. Now what you did, you stored the count of A here. A is 1, B is 2, and C is 3 in the first word. In the second word, C is 1, B is 2, A is 3. And when you just took the count and you sorted this count in increasing order, for first word you got 1, 2, 3. The third word you got 1, 2, 3. What this signifies? This signifies whether it is C, A, or B, this one, whether it is C, A, or B, this one in second word also, we don't care. We know that since the count is same, we can swap them, right? Here, we can just swap it. Like I can just cut this, convert it to A, correct? I can just cut this and convert this to C, right? So we got A, B, B, and C, C, right? This is the output we got from it. So even so, from here we can check. We need the thing sorting also to check whether all the counts are in in the increasing format or in the consecutive increasing format, or the counts are similar to the word 1 and word 2 for particular frequencies. So it makes us clear that we can swap the characters and convert it to or word 1 or word 2, vice versa. Fine, fine. So I guess from here we come to a conclusion, or yeah, we could see the conclusion here, that we took the length, we checked the characters, then we took the count for word 1 and word 2. This is 13. Fourth thing, sorting of the count to check whether we can swap the frequencies. When I say swap the frequencies, this is the operation 2. Okay. So from here we can understand that we don't actually need to swap the frequencies or swap in place the characters, right? So if you can just read it here, can we just remap the frequencies even if the letters match? As I said, we must check if the frequencies or occurrences of each Letter in word can be reassigned to the letters in word 2, because if the frequencies are not same, we cannot reassign the characters from word 1 to word 2 or word 2 to word 1, right? For that, we check the count and we do the sorting. We also need to check whether the length of the word are same or not, which we did. Fine. After this, we want to check whether the words can really be transformed. We can do it by sorting the frequencies, which we did it here in the fourth step. Fine. And why we did it? Because the frequency of both words comes out to be the same pattern, means we can transform them. Otherwise, there would be a case where frequency for each character may not be equal. Fine. This is the theory written here, but I explained the intuition how we're gonna build it. So from here, we can come to know that uh, for storing the uniqueness of the characters, we can use set. Fine, because set always store the unique characters. For storing the count, we can use dictionary. Fine. And for sorting, we can use the sorted method in Python. Anything else? No. So this set and dictionary comes in the logic of hashing. Okay, if we don't have the knowledge of set and dictionary, I will be making. If you don't have the knowledge of set and dictionary, you will be getting to know it in further slides. I hope you understood the intuition, how we build up the intuition and how the things are going, right? So let's move to the next slide. Before going to the approach, let's understand what is set data structure in depth. Okay, so a set is a built-in data structure in Python that stores unordered unique elements. Fine, these two things are important. It is particularly powerful when dealing with problems involving membership checks, duplicates removal, or mathematical set operations like union or intersections. Fine. Basically, if you do set one intersecting, set two, so you will get only elements which are common in both. Fine. And if you do subtraction, so it will give the values which are present only in set one and or in set two. Fine. Now, what are the key properties of sets? There is no duplicate elements. First thing, fine, checked. It is unordered, no indexing or slashing. Checked. It is mutable, can add or remove elements. Fine. Support standard set operations, which are here I will discuss with you. And why it is efficient. This is the important thing, right? Why we are using set in any of our DSA problems? Because testing is O of 1 average thanks to hashing. It takes only O of 1 time in average to do any application or operation of set. Eliminates duplicates automatically. Efficient. Useful in problems involving checking if elements repeat itself, basically duplicate element. Fast lookup whether this element exists in set or not, and comparing data sets. Fine. Now, what are the operations? Fine. Adding into the set, removing from the set, checking membership. Like if you go in add, right? So s dot add adds an element to the set. Fine. Remove s dot discard two. So removes if present. No error if missing. Basically, if two is present in set or not, right? Then remove it. Checking membership if three in s. Check if an element exists in a set or not. Fine. Union means what? S2 or S1. Okay. Any of the time. Union with S2. Fine. So if we have something values in set 1 and in set 2, and when you make the union of both of them, so it creates one big set of unique elements. Intersection is this common elements only, as I said, and difference, subtraction, items in S1 but are not in S2. Great. This is all about set data structure we should be knowing about for our solving any DSA problems. Okay, now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach, how we're going to solve it. Okay, first and foremost thing was checking the length. Let's take example as A comma A, sorry, AA, BB, CC, and other B, let it be BB, CC, and A, right? This is word 1, this is word 2. Length is equal, we written false, otherwise it's good, we continue, fine. This is the basic validation, says strings of different lengths can never be transformed into each other under the given operations. Fine. Now, second thing was counting the character frequencies. Now for that, since I said we could use dictionary, but to make it more optimized, we could create an array of 26 size which basically means 26 characters of the alphabets, English alphabet, right? And store the count itself, like how many counts of A is there, how many kinds of B is there, right? So that could be a much easier task to do, right? You can use dictionary also, but this is much more easier to do. Makes sense to do, I would say. So we create two frequencies arrays, word1 and word2 of size 26 for all lowercase letters. Now each index represents a character from A to Z. Zero represents index zero represents A basically. So yeah, that's the thing. And we loop through word one. After that, we try to loop through word one, and for each character, we increment the corresponding count in word one. So, like when we came to A, B, B, C, C, we came in this part, which what we did in word one, we took this character. I will just write it as character subtracted by ORD of A. Now we always subtract the character from A to get its ASCII value. Keep that in mind. Okay. So for ASCII value of small character A is 97. Fine. B would be 98. So it goes on. Fine. So this is the way we do it. Now we loop through word 2 and do the similar tasks. So what this helps us is that it helps us to count the frequencies. And since it uses only 26, since it is a 26 size array, it uses constant space. Fine. Which is basically like if this is a thing uh, in 0, we have count 2 times A. For B, we have 2 count in index 1, and similarly, we goes with index C. We have 2 count for index C for index 2. Fine. So this is how we store in W1 and W2 the frequencies of the characters. Now we know the frequencies, we know the length. Now we will check the uniqueness, right? Since even though length is equal, we need to find whether all the characters are same or not. Like if A, B, C, and D is here. So whether the other string also contains A, B, C, D in different frequency format or not. So, but if the other string contains A, B, C, E, so it is never possible, right? And since A could be multiple times, D could be multiple times, what we do, we use set, which always stores unique characters, fine. And after storing the values in the set, we check if set1 equals to set2. If both the sets are equal, which means okay, we are done with two things, which is length is done and the characters in both the words are same. As you can see here, compare unique character set. This is step 3. Characters from both strings. If the sets are not equal, return false. This ensures that no characters mapping violates the rule. Both strings must contain exactly the same characters. Fine. After that, what we do? After that, we try to sort the word frequencies which we stored, right? We sort the frequencies arrays word 1 and word 2 and we compare them, right? Because we want to check whether we are getting 1, 2, 3, 4 and 1, 2, 3, 4, right? So that we can swap them or swap their frequencies from character word 1 to word 2, which is basically performing operation 2. Like if at the end we don't have 4, we had 5, right? So this is not possible. That's the thing. Sorting helps check if frequency distribution can be reassigned to each other regardless of which characters hold them. Fine. Now, how hashing using set and dictionary, or you could say the word which we are using here, word W1, is helping us, right? Quick frequency tracking using a fixed size W1 and W2, which is the frequency count array which we are using, alphabets, like the alphabets which we are storing, right? Quickly encounter count character occurrences is O of n time with constant space for 26 characters only, right? Each easy duplicate detection is done by the set, which lets us instantly compare if both strings can use the same set of characters or not. And hashing avoids nested loops, enables a simple, readable, and optimized solution. So this is the reason. These three are the most common reason why we are using set and dictionary, or you could say the 26 character word array. Fine. I hope you understood the approach. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So This is the first criteria which we do. We check the length of the word one and length word two. If they are not equal, we return false. Then we create these two 26 size word one and word two alphabetic character array to store the frequencies. We loop through word one. We check. We just subtract it. Like suppose what this means is that 97 minus 97. How much? Zero, right? So when I do odd or well, we get 97. Or when we subtract something with in character, if we had some character here like B, we subtracted it. If B is 198, right? So 98 minus 97 gives 1. So the index 1 contains B character and its frequency. So this is what it does, right? And similarly for word 2 also we do the same. Then we check putting the word 1 and word 2 in set 1 and set 2, check whether they are equal or not. If they are not, we return false. And in the third step, I guess first step, this is the second thing. Third thing, this is the fourth step. Okay, we sort the frequency array and check whether the sorting is correct or not, or same or not. If not, we return false. Otherwise, we return true. Now, time complexity comes out to be O of n. Let me tell you why. Iterating well in word one or iterating word one takes O of n time. Word two takes O of n time. Fine. Then putting values in set one, just putting it there takes also O of n time. Okay, these three things are done. So 3 times we have O of n plus O of n plus O of n. Then in sorted, it takes O of n, not O of n square, not n log n. Because we know the size of the frequency array is 26 only. Now 26 log 26 gives a constant value. Fine, always. Which is something nearly 36 point something. Fine. So this is a constant value, right? That's why we take it as O of n, not it is n log n, but since we know that the size is only 26, it's considered as O of n. So our time complexity comes out to be O of n, and space complexity is O of 1 because these are constant space, the frequency arrays which we are taking, and we are not storing here anything in set, just we are putting the values and checking, so it does not count in a space complexity, and that's why the space complexity comes out to be O of 1. Fine. I hope you understood the code. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. First condition was to check the length. Fine. Length of word one is 336. Okay, it passes the first criteria. Now, second was taking the frequencies, right? It is 0 since we have only ABC here, so let it be 0, 1, 2 for word one. Fine. So A has frequency of 2 and B has frequency of 3. C has this is 3, this is 2, has frequency of 1. And word 2, 0, 1, 2. Let me write here A, B, C. Fine. A, B, and C. Here A frequency is 1, B frequency is 2, C frequency is 3. Fine. This is done. Now, second step was count frequency, which is done, right? Third step was using set to check characters. Fine. So if we put this in set, we get A, B, C. If we put this in set, we get A, B, C. So both are equal. So third check is also done. Now fourth check was sorting the frequency array. If you can see, if we sort the word one frequency array, we get 1, 2, 3, and word two array if we do, we get 1, 2, 3. So we return. This is also passed. So we return true. The end. That's why the output is true here. Now, if you want to see that how it's happening, like we did it without doing the sampling or anything, right? We just uses our common logic and intuition to build up this solution. But how it's gonna look like, So if word 1 is C, A, B, 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 and then A, right? And word 2 is A, B, B, C, C, C. If you can see, A is one time here and C is also one time here. So what if I try to convert word 2 to word 1? Fine, we are doing word 2 to word 1. So A is converted to C. This is done. Fine. Now we are left with this part and this part. If you can see, we can do the operation one, which is swapping. Fine. If we swap this, or we can do what? We can just convert word one to word two. That will make much sense. Fine. Let's me convert word one to word two. So in first, you can see that C is there, A is there, and here A count is one time and C count is one time. So you swapped it and you got A. Now here you can see that we have two A's and two B's. Fine. Swapped it here. So after swapping, what we got? We get A here and B here. Now we can see that there are two A's and two B's. We can swap it, right? We can convert these A's to B's. So we converted them to B's. Here we have three B's left and three C's left. We can convert these three B's to these three C's. So we get this. So word one becomes word two, right? So this is the way which we can do in visualized way, but we didn't have to do this since we knew these four steps are enough to complete the thing. Fine. Then here is another dry run. Let's take it in a short way. Like this A B C A C, and second is A B B C C. Fine. Your first case is of length. Length of 336. Length is equal true. Fine. Then we checked for the frequencies. Let's go for the frequency of word one, then word two. Fine. Now zero index represents like we edit here A B C. Fine. So zero index represents A. So how many A's are there? Three A's are there in word one, and two C's are there, and one B is there, right? If I'm correct. Yeah. And in second, we have two A's, two B's, and two C's. Fine. Our second thing, which is frequency, is also done. Now we have to check the uniqueness of the characters in both the words. So we have A in one, ABC we have in word one. Second word also we had only ABC. So this is also done. So our third condition, characters are also done. Fine. Now fourth is sorting. If I sort word one, I get 1, 2, 3. Fine. If I sort word two, we get 2, comma 2, comma 2. Now if you check that these are not equal, right? So it returns false. Sorry, false. Because you have one, right? And you don't have any one here, so you cannot, rearrange or replace them. If you see here, practically, if you practically try to visualize this thing, I have A, B, C, A, C, and A, B, B, C, C. But if I try to convert word one to word two, fine. So if you try to convert this, you know that, okay, you thought, okay, we have two C's, right? So you tried putting C here. So what it became like? It became like C came here and I think A was there, right? So A came here. Fine. So okay, these two matched. Great. Now you saw that B is here. So even if you put B in this side or this side, still you will have three A's and one B. If you think of changing this three A's with B, you cannot do it, right? To do that, you need three B's in word two and one A in word two. Fine. Then only it could be done. So that's why we return false. They cannot be same. I hope you understood this second try run also. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition and data structures like dictionary and set and the approach, then the code. After that, do a dry run by yourself on 2, 3 examples. I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and solution, let's move to the lead code and code the solution. Code is as simple as it can get. Like first, you will check the length. If length of word 1, if it is not equals to the length of word 2, we return false. Fine. Then we create a frequencies arrays of 26 size. Okay. Now for val in word 1, we try to count the frequency here now. Order of val minus odd of a. Okay. Now for the second word, ORD of val, ORD of a. This I explained you, right? So basically this will become, if there is a ASCII value of a is 97, right? So 97 minus 97 gives me 0. ASCII value of b is 98, right? 98 minus 97 gives me 1, right? So in index 1 we know that index 1 represents b, character b, fine. That is what it's happening here. And then we will check if set of word 1, if they are not equal, we will return false because characters also has to be same. And at the end, we just return sorted off in sorted form. We check if they're equal or not. Fine. Let's submit. Okay, our code got submitted. Let now finally submit the solution. We have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.